Hey guys, again, hey, welcome Mohawks to another thrilling and exciting stoichiometry practice problem. Today we're doing practice number 8, problem number 1. So it says, during a double replacement reaction in a lab, Mr. Nelson's class, students mix sodium sulfite with potassium nitrate to see if it precipitates or if a precipitate forms. During this reaction, the compounds sodium nitrate and potassium sulfite are created. So we're just going to go ahead and look at it again, and we have sodium sulfite with potassium nitrate. So those are our first two. So we're going to write down sodium sulfate. Now sodium is going to be a +1, and sulfite is a -2. Now let's go ahead and look at that. So here we go. We have sodium is right here. It's a +1. This is the +1 column. And again, if I went down to that other page 12, we'd see the same thing. But sulfite, where we get sulfite? Well, sulfite, we have to get all the way down and all the way down to the very bottom. Let's get an area. Sulfite here. So sulfite, SO3, it's a -2. So we have a negative or a +1 and a -2. So let's go ahead and go back to our problem. So we're back at the problem. So they do not cancel each other out. So what do? We crisscross. And so we have 2 sodiums and 1 sulfite. So we're going to have Na with a subscript of 2, and then sulfite SO4, but it's 3. Okay, so we're going to go subscript 3. So that's going to be our sodium sulfite. We saw that. We're going to add to that. Potassium nitrate. Now potassium again. We go over here, potassium is going to be a +1, and nitrate, on the other hand, is going to be a -1. And if we looked at our packet, again, we can see our packet. We can go ahead and go all the way down here to the bottom, and we can see that nitrate is a -1. Okay, if we get somewhere in the middle here, we can see that we have on page 12, we have potassium as a +1. So page 12 is a good one always to go to if it's an element by itself. If it's polyatomic, we got to go to that last page. So since they're 1-to-1, we know that we're going to have 1 potassium, and the symbol for potassium is K. Let's double check that with our periodic table. Okay, and we see right here that it is potassium. Potassium is K. So let's go back to our problem. And we know that we have a +1 -1, so we're going to have K. And then nitrate, if we remember, was NO3. And that's going to yield what it says right here. During this reaction, the compound, this one right here and this one right here, are created. So we have sodium nitrate. Sodium was a +1, nitrate was a -1. So we're going to have NaNO3. And to that, we're going to also have potassium sulfate. Now, potassium's a +1, okay, and sulfate's a -2, like you have up there. So we're going to crisscross. We're going to have 2 potassiums. So we're going to have K2, and then sulfite, which is SO. So there's what we have. Now we're going to go ahead and balance this skeleton equation. So we're going to go ahead and put some of these in here. There we go. Finally, I can do it right. So we're going to have sodium. So I'm going to put Na on each side. On this side, I look at it. I have right here. I have 2. Okay, so we're going to put a 2 there. I'm going to tab over to the other side. On this side, I only have 1. And on the next element, we have SO3. Now, again, if I have it on SO3 here and SO3 there, so we're going to do the same one. So it's going to be SO3. Okay. And on this side, There we go. And on this side, we have 1 SO3. And on this side over here, right there, we only have 1 SO3. So we're going to go ahead and get that over there. And so there's 1. And then after that, we have K. So on this side, our potassium, we have 1. And on this side, we have 2 right here. See 2 there and 1 right there. Okay, then we have our NO3. So we have NO3. We have 1 on this side and 1 on that side. So we're good on those ones right now. So what are we going to start off with? I can start off with my sodium, or I can start off with my potassium. So we're going to go ahead and start off with sodium, right? It's the first one up there, so might as well. So I have to put 2 right here. So I put a 2 right there, and that means I have 2 sodiums right here. So I'm going to change this to a 2. We'll get rid of this one right here. And it also tells me I have our sodium, our nitrates, nitrates is going to be 2 also. So we're going to highlight this one over here. Which means I got to go back over to this one right here. And I have NO2. I need it 2 times, so I have to come up here and we have to put a 2 there. Because I have it once, we need it twice. So we're going to put a 2 there. And we can get rid of this. And because I have 2 nitrates here, I'm also going to have 2 potassium. So I'm going to change this to a 2. Okay. Get rid of that, and it looks like I'm already canceled. So I have 2 and 2, 1 and 1, 2 and 2, 2 and 2. We're good. So our molar ratio is going to be 1, 2, 2, 1. So we're going to have 1 to 2 to 2 to 1. That's our molar ratio. And again, I like to make sure that these things right here are highlighted in green. So let's go ahead and highlight them in green, 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 and green. Okay, so now we have that. Now we got to do our molar masses. So I'm just going to bring this up a little bit here. Okay, our molar masses. Now our molar masses, we need them in this one. We need sodium sulfite, and that's what we have and what we're looking for. So just calculate the mass in grams of potassium nitrate. So I'm going to start out with sodium sulfite. So sodium sulfite is right here. So I'm going to copy this one. And I'm going to paste it right here because that's one of them that I'm going to look for. And then I also need potassium nitrate. Now potassium nitrate is going to be right here. So I'm going to copy that one. And I'm going to paste that one. Okay. So now what am I going to do? Well, I'm going to go ahead and do the molar masses. Now remember, this is how much 1 mole weighs. So 1 mole weighs whatever the weight of all of them is. So we have sodium. We have it 2 times, I believe it's 23. But let's go take a look at our thing. Our sodium is right here. It is 23. Okay. So let's get back to this, and that's going to equal 46. Okay. I also have sulfur, which I have 1 times 32 equals 32. But let's double check and make sure that sulfur is 32. Here's sulfur. It is 32. There we go. And then I have oxygen. Okay. I have oxygen. But I have it 3 times. 3 times 16 equals 48. Now let's just double check that one on the calculator. So let's go over here. And if we can say that we have 3 times 16 equals 48, that's correct. Okay, so now one of the things that we can do is we can find our totals. It's going to be all those added together. So I already have 48 in there, so we're going to add to that plus 32 plus 46 equals 126. Our total is going to be 126 grams. That's going to be per mole, and that's 1 mole. Okay. I like to make sure that we have this, again, highlighted in green because it's the final answer. And these are going to be highlighted in yellow. Okay. the more that you can organize how these things are go through, the easier it will be for you. Okay, so now we're just going to go over to the next one and get all these over here. Okay. Okay, so let's go ahead and look at the next one. We have potassium. Okay, and we have potassium 1 times, and we don't know what it is. I think it's 39, but let's double check that. Let's go ahead. Potassium's right here. It is 39, so let's go ahead and go back. So 1 times 39, that's going to equal 39. Okay, then we're going to have our nitrogen, our N. We only have one of those, and that's going to be times 14. So let's double check that again. Nitrogen's right here. It is 14. Okay, and so that's going to equal 14. And then my next one is going to be oxygen. And so we have oxygen. And we have that 3 times. That's 16. And as we head over here, it's going to be 48. And that's going to equal 48. So we're going to go ahead and total those up over here on the calculator. So we're going to take 39 plus 14 plus 48 equals 101. So my total over here is going to be 101 grams per mole. Okay, so let's go down to the stoichiometry problem. And it says, after you have balanced the above chemical equation, calculate the mass in grams of potassium nitrate needed to completely combine with 152 grams of sodium sulfite. So we have to start with our number that we have at the beginning. So we're going to start with 152.6 grams of sodium sulfite. That's this one right here. So I'm going to take this one right here. We're going to copy it. And we're just going to paste it right here. Now, again, I like to make sure that we're not highlighted or anything or bold or anything else like that. So we're going to go back to this and we're going to multiply that by. Now, we're going to put grams on bottom and grams on bottom, moles on top. And we're going to put this number here on bottom and this number on top. And what number goes with moles? 1. So we're going to put 1 mole. Okay, and we're going to do this. 1 mole of, and we're going to paste that. And we need to make sure that that is lowercase. Okay, now I want to copy that. And we're on the bottom, we're going to put down our 126. So 126 grams of that, and we're going to unhighlight this, whatever the reason that is highlighted for, and put none. Okay, so we're going to multiply this by, now this is our molar ratio. Now one thing we have, we have moles of sodium sulfite here, so we're going to go up here and say that's going to be 1 mole of sodium sulfite. So 1 mole of sodium sulfite is going to equal, we're looking for potassium nitrate. So if we go up here, potassium nitrate, it's going to be 2 moles of potassium nitrate right there. 2 moles of potassium nitrate. So we're going to go over here and we're going to put down, this was going to be 1 mole. And this is going to be 2 moles of potassium, KNO3. Okay, so now we're going to go ahead and put our last ones in. So I know that I'm going to have KNO3. So we're just going to copy that. So again, I got to put moles on bottom. I have moles on top up here. So we're going to put 1 mole of KNO3 over here. And 1 mole of KNO3 equals 101 grams. So we're going to put 101 grams of KNO3 up there. Our equal sign, and then we know that we're going to have so many grams of KNO3. Okay, and one thing again I have to put right here is how many sig figs. Well, look at 1, 2, 3, 4. So we're going to have 4 sig figs, and I like to highlight that in a different color. that we haven't done before. We're going to go ahead and underline all of these because really that's where they underline. We have our times in a line. That's where our line comes in. So you'll see that we have times in a line. Okay, now we're going to get rid of everything that we can. So we're going to get rid of grams of sodium sulfate there and grams of sodium sulfate down here. And I have moles of sodium sulfite here and moles of sodium sulfite down here. Now notice I'm not getting rid of the numbers, I'm just getting rid of the units. I have moles of potassium nitrate here, and I have moles of potassium nitrate here. Again, I can get rid of these and I can convert from grams of sodium sulfate to grams of potassium nitrate because of this center one here. Because 2 moles of potassium nitrate equals 1 mole of sodium sulfite. As long as I have a balanced chemical equation, we can do that. So now all we have to do is our math. And so we're going to start off with 156. So I'm going to come over to the calculator. We're going to clear it. And we're going to put 152 point, excuse me. Let's get rid of that. 152.6. We're going to multiply by the top, divide by the bottom. So I have multiply by 1, which I don't have to do. So we're going to divide this by 126. So divide by 126. Then we're going to multiply by 2. I don't need to divide by 1. And then we're going to multiply by 101. And that's going to equal 244.6444. So 244.6444. We don't even have to really go that far. Okay. But we do have to go 4 significant figures. So we have to go 1, 2, 3, 4. And this is where we put our line. And I always, again, like to insert. And since here I know that it's below 5, I'm going to put one that says I'm going to go down. Okay, so we're going to round that down. And sometimes I even like to make sure that's a nice bright color. You know, and maybe even try to make it bold or something. Or even make it larger sometimes, just so we can see it. So there we went over, and so we're going to drop this off. So we drop that off, so our answer over here is going to be 244.6. That's going to be grams of KNO3. Okay. And again, I like to make sure that we all stay in together, so we'll just go ahead and get rid of some of those. There we go. So that's our number right here. So that's our theoretical yield. The theoretical yield is if everything converts over, if everything works out. But in real life, it really doesn't. So we have an actual yield down here. We have an actual yield of 201 grams. So what is the percent yield? Well, the percent yield, okay, so PY is going to equal our actual yield. Okay, and then we're going to divide that by our theoretical yield. Okay, now again, your actual yield it should almost always be less. So we're going to underline this right here. Make it look better. And then what we normally do is we multiply that by 100. Okay, so that's going to equal. Our actual yield is 201 grams. We're going to put 201 grams on top. And on bottom, we're going to come over here and we're going to put down our theoretical yield, which is this number right here, which is 244.6. Okay. I'm going to multiply that by 100. That's going to equal, and that's going to be 100. Again, I haven't said anything, it should be 100%. Okay. Okay. Step over, we'll underline this right here. And so now we're just going to go ahead and do our math. So let's go back over to our calculator, and we're going to take 201, and we're going to divide that by 244.6 equals, then we're going to multiply that by 100, and that's going to equal 82.174. So we're going to write that down, 82.174. I don't need to go any further than that because when we do a percentage, okay, percentage only goes one number after. So that's what this says, round one number after. So we're going to round right there. Okay, so we're going to insert something, a special insert in there. In this case, again, we're going to go up. Okay, let's highlight that, make that a different color. Or, excuse me. So we're going to be 82.2. So come in here and put 82.2. Okay. Again, I like to have something after that. We're going to go with that, and that's going to be of what? Of KNO3. And there's our final answer. We've got it set up right now. So again, I like to again put KNO3 there. This number right here should be done in yellow, along with this number right here, because these are ones you get points for. I see all these right here. I see them in the right color. That's good. I always like to have this also in yellow. Okay, this one in yellow, because these are numbers that you have to put in. Okay, so wherever you put in numbers, you're getting points. Okay, and then make sure everything's crossed out. As long as everything's crossed out, we should be pretty good with our number. So, hey, once I get finished here, we're pretty much done with this question, and let's just go ahead and highlight that one. That's our last one to highlight. There we go. There's our answers. 82.2% is our percent yield. Our theoretical yield was 244.6 grams of potassium nitrate. And our balance equation, our molar ratio was 1 to 2 to 2 to 1. Hey, as always, go Mohawks. Nelson out.